What's good, y'all? Welcome back to another video. Today we're going to be going over logarithmic differentiation. What is it? When do we use it? And how to use it? So without further ado, let's get right to it. Right. So, what is it? Essentially what logarithmic differentiation is a way to use logs or natural log more specifically in order to differentiate certain equations. Now, why would I do that, right? Logs are already complicated. Derivatives are complicated. Why are we combining these ideas? Well, there's going to be a lot of times, especially as you start getting into more product rule, chain rule, quotient rule, things like that, where doing all that stuff gets really, really messy, right? For example, if we're especially with trig, we got chain rule within chain rule within chain rule, and maybe it's a fraction, so you have quotient rule or product rule in there. And then all of a sudden you get this massive differentiation that we have to simplify all the way out. It takes forever. There's a lot of room for a lot of little errors. It sucks. So that's what logarithmic differentiation solves. Essentially what we do is we use the idea of log rules, right? The addition, subtraction, and power rule that are associated with log or natural log. And we use that in order to kind of bypass the idea of chain rule and product rule so then we can make it a lot easier on ourselves. Now I'll kind of explain that in these next couple questions here. So this first one, we got 6x minus 4 squared, 2x squared plus 3 squared. Okay, so if we were to do this normally, well, first thing I'm seeing is I'm seeing chain rule, I'm also seeing product rule. This would get really long and really annoying. But this is where logarithmic differentiation comes into play. So what I'm going to do, the first thing I'm going to do is I'm going to take the natural log of both sides. So I'm going to take the natural log of f of x is equal to natural log of 6x minus 4 squared 2x squared plus 3 squared. Now you're already probably telling me, like, hey, this already looks more confusing. Give it a second. Remember with logs and log rules, anytime you have two things getting multiplied together in a log, we can rewrite it as those two things separated but added together as long as we use the same base. So what I can do is I can rewrite this bottom part as the natural log of 6x minus 4 squared plus the natural log of 2x squared plus 3 squared. Now notice that's already getting away from the product rule, right? Now it's not multiplying together. So what else can I do? Well, I can also get rid of the exponent. Remember, with logs, I can rewrite this whole entire thing with the exponent in front. So I can actually rewrite this as 2 times the natural log of 6x minus 4 plus 2 times the natural log. Well, I didn't mean 2 natural log 2x squared plus 3. Boom. Just right there, I've gotten rid of so much stuff in terms of chain rule and product rule. And so now I can take the derivative of this thing without having to deal with all that extra stuff. So, let me erase this. Got more space here. So what I'm going to do is I'm going to take the derivative of both sides. If I take the derivative of the natural log of a function, well, the derivative in and of itself is just 1 over the x value. So in this case, it's going to be the derivative of the left side is going to be 1 over f of x times a little bit of chain rule here, f prime of x is equal to. Now, I'm going to take the derivative of both of these, and I don't have to worry about the product rule whatsoever. So, 2 times the derivative of the natural log. Anytime you take the derivative of the natural log, it's going to be 1 over whatever's on the inside. So 1 over 6x minus 4 times the derivative of the inside. This is still chain rule, but you can already see it's a lot easier. Plus, and now we do the same thing here, 2 times 1 over 2x squared plus 3 times 4x. And then from here, all I'm going to do is I'm just going to simplify. So this whole thing becomes, well, 2 times 6 is 12. That goes into the numerator, so I have 12 over 6x minus 4 plus, well, 2 times 4x in this case, 8x over 2x squared plus 3. And this is all times f prime of x over f of x. So just kind of notice that I did this in terms of squared. I'm just going to change this real quick. It doesn't change any of the math. The math is the exact same. So yeah, that brings us here. Now, what's next here? Well, what's next is this the derivative? Well, no, not exactly, not yet. Because right now I have this as f prime of x over f of x. So what I have to do is I'm trying to solve for the derivative of this function, so just f prime of x. So what I'm going to do is I'm going to multiply everything times f of x. And what that does is it essentially cancels this right here. And then I just have to multiply it by all the terms over there. So this whole thing ends up equaling the f prime of x equals, well, f of x, which is this thing here, so 6x minus 4 squared 2x squared plus 3 squared, all times this right here, 12 over 6x minus 4 plus 8x over 2x squared. And that's the final answer there. So again, if we had to go through product rule, chain rule, and all that type of stuff, this would be very long, very complicated, and a lot of ideas. Now, don't get me wrong, this answer is still very long. I'm not saying that it isn't. But the idea is I'm bypassing all of those complicated differentiation rules just so that I can differentiate more simply, and so then the process is a little more smooth, right? We're mitigating our room for error, essentially. So we'll get to that next one. All right, here's the next one here. Now this is the definition of messy, right? I'm seeing chain rule, I'm seeing product rule on top, I'm seeing the possibility of quotient rule. If you don't want to use quotient rule, then you have to turn this into a negative exponent, and then in that case, even more product rule, right? This thing would be long. So again, what can we do? Well, what I can do here is, again, logarithmic differentiation. That's going to make this thing so much easier. So I'm going to take the natural log of both sides. Natural log, do this a little bit lower here. Natural log of f of x equal to natural log of this whole entire thing. I'm going to just put u here just to show that's all it is. And that's going to end up equaling the natural log f of x equals, I'll put it down here. This is multiplication, so I can rewrite that as addition, and both of these exponents are going to go out in front. So the natural log 9 natural log x plus 6 natural log x minus 3. And again, log rules state that anytime you're dividing, we can rewrite it as subtraction. So minus in this case, again, the exponent's going to go out in front. 3 natural log x squared plus 2. So there we have it, right? 9 natural log x. I just moved the 9 out in front. Natural log x plus. The reason why it's plus is because this is multiplication. Log rules state anytime you're multiplying, we can rewrite it as addition. Plus 6, move the 6 out. Natural log of x minus 3 minus, again, exponent goes out in front. 3 times the natural log of x squared plus 2. And from here, we differentiate. So the natural log of x is 1 over x times 9. This is going to be 9x plus 6, and the natural log of, 6 goes out, and that's going to be 1 over x minus 3. X minus 3. And chain rule, but in this case, it's just x, so it's just 1, so it stays the same, minus 3 times, in this case, it's going to be 1 over x squared plus 2 times, and I had to take the derivative of the inside, so 2x. If I simplify this whole thing, I'm going to get f prime x over f of x equals 9 over x plus x over, or 6 over x minus 3 minus 6x over x squared plus 2. And that's the differentiating, right? Just imagine how annoying that would have been, doing all of the, like the quotient rule, product rule, all that type of stuff. And in here, it's all separate. They're all added together, so none of that stuff is going to happen. A little bit of chain rule, but again, it's very minimal. And then we're all set, just like that. So again, just like I said last time, are we done? No, we're not. Because this isn't solving for f prime of x. This is solving for f prime of x over f of x. So what we have to do here is I have to multiply every side times f of x. Let me give myself some room here. I don't know if up here is going to help, but better safe than sorry. I'll write it along the bottom here, actually. This whole thing is going to be x9 times x minus 3 over 6 divided by x squared plus 2 to the third times 9 over x plus 6 times over x minus 3 minus 6x over x squared plus 2. Leaving us with this complicated but far easier to solve answer, right? This would have taken forever. There would have been so many room for errors, all of that, but we just ignored all of it and get the answer a lot simpler, a lot easier way. I hope you guys enjoyed. If you guys ever have any questions, feel free to drop them in the comments. But until then, see y'all next time. Take care. Peace out.